Okay, go ahead. So we have 12 steps on the slide here. Which one is the first one? What is the first thing we need to do to perform a chi-square test? Go ahead.
Number 11, Doctor.
Number 11. Good. So number 11 is done, right? So it's rearrangement of the data, meaning you omit the zero groups and put the data in descending order, adjust the limits of the first and the last group to infinity and minus infinity. Okay. Second, what do you do after that? After you rearrange the data, what's the next step? Five. What is 5? Yeah, calculating z value for the upper limits. Yes, good, correct. So you take the upper limit of each group and calculate its z value, which is value minus mean upon standard deviation. Okay, next, after you get the z value, what do you do? F4, which is no, no, that's not correct. 4 is not correct. For z value, you have the z values now. What should you do after that? 8. What is 8? Yes. So you have the z value. Find out the probability of the z value from the table. And these probabilities I told you are cumulative probabilities. Okay. Now what's the next step? Hashim? What's the next step? 4 now. Yeah. Now you find out the probability of each group. From cumulative, find out for each group. Okay. Next. After 4, what do you do? 10. No. 10 is not correct. Probability for each group. Then what? 6. Yes, find out theoretical frequency, the f values. So you multiply the probability with the total number of values, you get theoretical frequency, the f values. Okay, you found f values. Now what? After you find the f values, now what? You just have to look at the red step, right? The steps in red color. Ten merging groups? No. Before that. Why should I merge? Look at the steps which are available and then answer. Why should I merge? 1, yes. First of all, check if you need merging or not. Okay, so the check is also always there. Should be 5 or more. F value should be 5 or more. Okay. Now what? After 1, now what? You applied the check. Theoretical frequency should be 5 or more. And now what you do? Now you do 10. Yes, good. So now merging if required. If required. Okay. Some cases merging may not be required. Okay. Then after merging, what do you do? Which is calculating chi-square for each group. Good. Very good. Next, after you calculate the chi-square for each group, then what do you do? 12 and 7. 12 is this. So 12 should be the next one. Good. Then you find out degrees of freedom. Okay. Up to 12, we did that in the class. Okay. So you can still tell me the steps, but let me briefly explain what do we mean by finding out degrees of freedom. Okay. So the steps which you did not cover, I'll explain them as well for the others who have not seen the video. Okay. So finding out degrees of freedom means what? Okay. Degrees of freedom refers to the variation in the data set. How much variation in the data set you have? Variation in the spot speed data is because of the number of speed groups. If I make more groups, there will be more variation in the data. Okay. So degrees of freedom is related to variation in the data, which is dependent upon number of speed groups you have. Okay. Minimum number of groups which you can have is 3. Okay. So variation starts after 3. Okay. So degrees of freedom will be number of speed groups you have minus 3. Number of speed groups minus 3. Now in this there is a small issue which you have to take care of. We have degrees of we have number of speed groups initially, and then we did some merging, right? So there was some merging here. In the first 3 groups and the last 2 groups, there was some merging. So the number of speed groups have now changed. Whatever the number we had earlier is not the same now because of the merging. Obviously, if there was no merging, then the number remains the same. Okay, but now we have the merging. So after merging, how many groups we have? So I have to count it from here now. I have to count it from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. I have 14 groups now after merging. Okay. Easier way to remember it is how many chi-square values you have. So obviously you calculate the chi-square value when you have already satisfied the f limit. Okay, so merging is already done, then you start calculating the chi-square value. So how many chi-square values you have calculated? Again, the answer will be 14. Okay, so degrees of freedom will be 14 minus 3. For this data set, degrees of freedom will be 14 minus 3, which is 11. Okay, so we have 11 degrees of freedom. Okay, now tell me the next step. So you find the degrees of freedom, which is 11 in this case. You count the number of speed groups you have, or number of chi-square values you have, minus 3. That is the degrees of freedom. Now what should I do after that? After I find out the degrees of freedom, what should I do? So I have only left with 2 and 9. So which one should be done first? Should I do 2 or should I do 9? 9. Yes, yeah. Find out the probability of chi-square from the table. Okay, now let me go to the table and show you how to find out the probability. Okay, so you found the total chi-square value 11.6669. Total chi-square value is 11.6669. What is the probability of this chi-square value from the table? This is the chi-square table. Okay, so degrees of freedom are in the first column. Okay, towards the left in the first column. So what were my degrees of freedom? 11. Okay, so I have to look into this row for my chi-square value. Now when you go from left to right, the values are increasing. Okay, so you always read it from left to right in the increasing order, the ascending order. So if I keep on going in this row from left to right, you reach 10.34 and the next value is 13.7. Okay, and after that it will be more than 13, right? So 11.6669 is between these two values. 11.6669 is between these two values. Okay, so the probability of 11.6669 will be the value between the probabilities of these two values. What is the probability of chi-square? To have 10.34, that is 50%. What is the probability of chi-square to have a value of 13.7? 0.25 or 25%. Now 11.6669 has a probability between 50% and 25%, or between 0.5 and 0.25. Now to find out, I do interpolation, right? I do interpolation. Okay, so this is like my, these are like my y values and these are like my x values. Okay, now actually I don't have to do interpolation. I can give you the answer even without interpolation. Okay, but just for the sake of refreshing your minds, I will tell you the procedure for interpolation as well. I will quickly brief it to you. So the basic equation for interpolation is x minus x1 divided by y minus 1 equals x1 minus x2 divided by y1 minus. Okay, this is the basic equation. Now what is x? The chi-square values, and what are y's? The probabilities. Okay, so x is the chi-square value which I have, 11.6669. What is x1? The chi-square value which I had before that, which is 10.34. What is x2? The chi-square value I have after 11.6669, which is 13.70. Okay. Then the y values, I'm trying to find out y, the probability at 11.669. So I don't know the y, but I know y1, the probability at 10.34, which is 0.5, and I know y2, the probability at 13.7, which is 0.25. Okay, so you put these values in the above equation, you will find out the value of y. That will be the probability of chi-square equals to 11.6669. Okay, like I said, you don't have to do this in this question. Okay, why? Because of the limit which we are trying to test. The limit which we are trying to test for the chi-square value is 5%, 0.05. Okay, so I'm only interested in if the y is 5% or less. Okay, less than 5%, whatever value it has, it's same for me, and more than 5%, whatever value it has, again it is same for me. It will give me the same decision, same result. Okay, so I'm only trying to check whether y is more than 5% or less than 5%. Now in this case, you are interpolating between y1 and y2. Y1 is 50%, y2 is 25%. So if you interpolate between 50 and 25%, can you get a value of less than 5%? No. So whatever value of y you get from this interpolation, I am damn sure that it will be more than 5%. Okay, 100% sure it will be more than 5%. If you find a way to calculate a value of less than 5%, that means you have a problem, a big problem. Okay, so the y value which I am trying to achieve is 5%. Okay, and whatever value I will calculate from this interpolation will be more than 5%. Okay, so if now what is the decision then? Okay, what happens if the value is more than 5%, and what happens if the value is less than 5%? If the value is more than 5%, it means that there is no significant difference between the spot speed data and normal distribution. If the probability of chi-square is 5% or more, it means that there is no significant difference between the spot speed data and normal distribution. Okay, if it is less than 5%, then it means that my data has significant difference with normal distribution, so it does not follow normal distribution. Okay, so if you remember, this was the main objective of doing the chi-square test. The objective was to mathematically prove that spot speed data follows normal distribution. We discussed another approach before, which was looking at the shape of the frequency distribution curve. So we said if the frequency distribution curve is bell shaped, normal distribution, otherwise not. That was a graphical approach. In cases where graphical approach is not valid, you cannot apply it. You can apply the chi-square test to know if the data follows normal distribution. Okay, so the test is very simple. Find out the probability of chi-square. If it is 5% or more, data follows normal distribution. If it is less than 5%, the data does not follow normal distribution. Okay, clear? So the steps which we did not do before the break, I have tried to explain them. Okay, any questions? So again, like I said, you don't have to do interpolation because So interpolating between 25 and 50%. That will be more than 5% in any case. Any questions? And I would request people who remember what we were doing before the break, only they ask the question. Okay, people who did not remember, then you need to go back and check what we were doing before you ask any questions. Without that, your questions will not be valid. Okay, any questions, any queries? Okay, if you go into the slides, you will see a very long example being done in the slides, which cover basically all the topics which we have done in this, covers all the types of calculations which we have done in this topic. Okay, the answers are given, the question and answer both are given. Go through it, practice it yourself, do the calculations yourself, see if you are getting the required answer or not. If you have any problem, you ask me the question. Okay, so there's a complete solved example done in the slides, which is covering all the types of calculations we have done in this topic. Chi-square and mean, median, mode, everything is done. Okay, so check it. If you have any questions, let me know. Okay, so now I will move to the next topic, which is from the same chapter. So we were doing it from chapter 11. The topic of spot speed was from chapter 11. So the next topic is also from chapter 11, which is travel time and delay studies. Travel time delay studies. And you can imagine that travel time and speed are interrelated. If I know the travel time, I can know the speed, right? So that's why they are in the same chapter. Now what we will do in this chapter today is find out why we do travel time studies and how we can do travel time studies. So why and how, this is what we will do today. Before we go into the discussion, the main point, which is the first point in this topic, is the difference between a travel time study and a spot speed study. Okay. Now using travel time, you can find out the speed. Using a travel time study, you can find out the speed, but that speed will not be called as a spot speed. Okay, because for spot speed, the travel time is taken for a very short segment. If you remember, few hundreds of feet. But when you are doing a pure travel time study, then the segment is very long. Okay, the travel time is observed for a significant length of the highway, and that significant length of the highway can be one whole segment. It can be the whole complete highway as well from start to end, or it can be a route as well. So route will have multiple highways. Okay, so for example, route to go from Isa town to Manama, or to go from Isa town to Safed, it will not have one highway, it will have multiple highways. Okay, so if you found travel time, if you observe travel time for a particular route, you cannot use that travel time to find out spot speed. That will be wrong. That is against the definition of spot speed. So if you are using time, distance upon time approach to find out the spot speed, then the distance would be very short in that case, only few hundreds of feet. But if you are doing a pure travel time study, then the distance will be longer than that, much longer than that. Like I said, at least one complete segment. One complete segment can be in kilometers. Okay, it will not be few hundreds of feet. Okay, so just keep one thing in mind. Data which is taken from a travel time study cannot be used in a spot speed study, because in that case the distance should be very short, but in travel time studies the distance is very long. Okay, a part of travel time study is to find out the delay as well, the delay during the travel. This most of the times it is part of the travel time study. Okay. Now, why do we do travel time studies? Travel time studies are done to find out the problem locations, problems where traffic flow has a problem. Okay, locations where traffic flow has a problem. Okay, for example, problem of congestion, problem with the design of the highway, problem with the maintenance activities, construction activities. So wherever these are there, wherever we have these problem locations, what will happen to the travel time? It will be higher. Okay, so higher travel time is basically an indication of a problem location. So if a segment has a very high travel time, then that segment is a problem location. Another objective or another use of travel time study is to find out the level of service. You see the word here, LOS. LOS stands for level of service. Okay, so you can find out level of service of different highways using travel time studies. What does level of service indicate? It indicates the quality of traffic flow. Quality of traffic flow. So if the flow is smooth and fast, travel time will be less, and vice versa. If the flow is facing stops or it is going slowly, then travel time will be higher. So quality of flow can be measured using travel time studies. Travel time studies or travel time itself can be used as an input for traffic assignment models. It can be used as an input in traffic assignment models. What are traffic assignment models? These are models or equations which tell you the proportion of trips going from one area to the other on different highways. These are models or equations which tell you the proportion of trips between two areas on different highways. So for example, I want to go from Isa Town to Manama. Okay, I have three possible highways which I will take. Okay, or let me rephrase it. I have, let's say, 1,000 drivers going from Isa Town to Manama, and these 1,000 drivers have three different options to go from, three different highways to go from Isa Town to Manama. Okay, out of these 1,000, how many will go by A, how many will go by B, and how many will go by C depends upon the travel time. Okay, so the highway which has the least travel time will have the highest proportion of drivers, and vice versa. Okay, so when you are calculating the number of trips between two areas on a specific highway, it depends upon the travel time. Okay, and I think you should understand the idea quite easily that highway which has least travel time, most of the drivers will be desiring to go from that highway, right? So travel time is an input in those equations which calculate the proportion of trips on a highway between two areas. Then travel time can also be used for economic evaluation. Okay, so whenever you are constructing a highway, one question you have to ask yourself is, what will be the change in travel time which I can bring with the new construction or the improvement of the highway? What will be the change for the travel time? Okay, so for example, the earlier travel time was 30 minutes. Now you build a bridge and the travel time reduced from 30 to 20 minutes. Okay, and there are 10,000 drivers on that highway. So for those 10,000 drivers, you are reducing the travel time for each one of them by 10 minutes. So 10 into 10,000 is 100,000, right? So every day you will save 100,000 minutes for the drivers. And then you can convert these minutes into money for economic evaluation. So each minute is, let's say, 100 fils for me. Okay, or 200 fils or 500 fils, whatever. Okay, so travel time, reduction in travel time is one of the major economic justification for improving or constructing the highways. Okay, then developing time contour maps. This is another function of travel time study, developing time contour maps. Now we will discuss time contour maps in detail later on, but for the time being, I'll just give you the main idea. But for that, tell me, what do we mean by a contour map? A contour map means what? And you have studied it in surveying, okay? So that's your hint. So when you are studying contour map in surveying, what does it mean? What did it mean there? If somebody gave you a contour map, what was it showing? What does a contour map show? Anyone? Contour map? The elevations, yes, the elevations. Anyone else wants to elaborate, or Hashim, you want to add something to it? How does it show the elevations? Anyone? Raneem, Zahra, yeah, Muhammad. Anyone? How does it show the elevation? Each line represents an elevation. Yes, good. Zahra, good. Passing through that line. Yeah, okay, good. Haneen, very good. Okay, contour lines. So contour lines are lines which are showing the points having the same elevation. Yeah, okay. So you have woken up. Okay, that's good. Same thing is shown in a time contour map. Okay, but in terms of time. What was shown in terms of elevation in a normal contour map, the same approach is taken in a time contour map, but to show the travel times. Okay, so in a in a contour map, in a surveying contour map, the lines are showing points of same elevation from a reference point, right? In a time contour map, the lines are joining the segments of same travel time from a reference point. Okay, so in a time contour map, there are lines which are showing the travel time of segments from a reference point. Okay, so the shape of the map is the same, the approach of drawing the map is the same, but the only thing is the change in data. There the data was elevation, here the data is travel time. And don't worry, I will show you with an example later on travel time contour map. We will discuss in more detail there. Now, how do we collect travel time data? There are different techniques to collect travel time data. The most accurate and the most commonly used technique is test car technique. Now, what is a test car? It is a car which you will drive over your required segment to observe the travel time. Okay, so this car belongs to the observer. Okay, this car belongs to the observer. So the observer is in the car with the driver, stopwatches, pen and paper. Okay, so the car will start driving from point A. The observer will start recording the time. It will reach the end point. The observer will note down the total travel time. Okay, and when the car is passing through different points between the start and end, the observer will also record that time as well. So when from point A, when did it reach point B, when did it reach point C and D, and till the end. Okay, so this is the job of the observer. Another thing which the observer will also record or should record is for how much time the car was stopped and what was the reason for stopping. So stopping or delay is part of the travel time, right? It's part of the travel time. So between any 2 points when the car stops, the observer will record for how many seconds the car was stopped and why the car was stopped. So it may have stopped because of the signal, because of an accident, because of traffic jam, whatever the reason is. The observer will record it. Okay. In some cases, the observer may keep 2 stopwatches, one for travel time, one for delay. Okay, so the travel time stopwatch will be running continuously from start to end. Okay, and whenever the car will pass a particular point, the observer will record the time from the stopwatch, that is stopwatch, and the other one will only be used when the car stops. So if the car doesn't stop, the other stopwatch will remain as it is. It will not be used. If the car stops, the observer will start the other stopwatch and he will record the time of stopping from that stopwatch. Okay. Another advanced variation to test car technique is instead of using the observer, you equip the car with distance and time measurement devices. And the distance and time for stopping and moving is automatically recorded by these devices. Okay, something like an odometer, but not the odometer itself. We need advanced devices which can record distance with respect to time. So if you have advanced GPS receivers, they can also do the same thing. Okay, advanced GPS receiver, which is designed for finding out the locations quickly, it can also do the same thing. So you can put the GPS receiver in the car, drive the car. After you come back, you can download the data, and the data will show the distance and the time, and you can note down everything from there. Okay, but obviously everybody does not have access to these advanced GPS receivers, so most of the times it is done with an observer. Now, test car technique can be applied in 3 different ways depending upon the type of highway and your requirement. What are you trying to find out? Okay, so there are 3 different ways or 3 different methods of applying the test car technique, and these methods are floating car, maximum car, and average car. Floating car, maximum car, average car. I will go through each one of them, starting from the bottom one. Okay, the last one, average car, but this is the easiest one to understand. In average car technique, you ask the driver to drive normally over the segment. No restrictions on the driver. Okay, but the highway on which this technique is applied is a multi-lane highway. It must be a multi-lane highway. Average car technique is applied on a multi-lane highway. Multi-lane highway means what? That each direction will have at least 2 lanes. Each direction will have at least 2 lanes. Okay, this is a multi-lane highway. So an average car technique is applied on a multi-lane highway, and the driver who is driving the test car does not have any restriction on him. So he will drive like he is driving normally, like nobody is observing him. Okay, nobody is observing him except God. Okay, so he will drive normally. If he wants to be in the right-hand side lane, he can be in the right-hand side lane. If he wants to overtake a vehicle, he can do that. There is no restriction on the driver. Okay, just he will drive, and it should be on a multi-lane highway. That's it. In maximum car technique, you will apply again on a multi-lane highway. Maximum car technique is also applied on a multi-lane highway, but with an extra restriction on the driver. And the extra restriction is the driver should try to go as fast as possible within the limit. Within the speed limit of the road, the driver should go as fast as possible. So the driver is driving in his lane and the other lane is empty. Now it is his responsibility to go in the other lane and go faster. He cannot say, no, I'm driving very comfortably in this lane, I don't want to change. No. If he can go faster from the other lane, he should go to the other lane. And remember, I'm talking about still multi-lane highways. Okay, so there are 2 or more lanes in each direction. Okay, so I'm talking about going to the other lane in the same direction. If a car is going in front of him, he has enough chance to overtake that car, he should do that in maximum car technique. Okay, if there is too much spacing between him and the car in front, and he can reduce the spacing by going faster, he should do that. Okay, so in maximum car technique, the driver has an added restriction that he should try to go as fast as possible whenever the chance comes, but under the limit. Okay, so once you take the travel time, you can calculate the speed of that segment, right, using the travel time. The speed which is taken or which is calculated using the travel time of maximum car technique is assumed to be the 85th percentile speed of that segment. The speed which is calculated using the travel time of maximum car technique is assumed to be the 85th percentile speed of the segment. And what do we mean by percentile? Just to refresh your mind, percentile is the upper limit for a specific proportion of the travel. So 85th percentile is the upper limit for 85% of the travelers. So you find out the travel time using maximum car technique, and you find out the speed using that travel time. That speed is, let's say, 65 miles per hour. So 85% of the drivers are driving at 65 miles per hour or less. This is our assumption when we take the speed from maximum car technique. Then we have floating car technique. What do you mean by floating car technique? So first of all, floating car technique is applied on 2-lane highways. 2-lane highways. 2-lane highway mean what now? 1 lane in each direction. So each direction only has 1 lane. Okay. So in floating car technique, you are interested in finding out the travel time on 2-lane highway. And what is the restriction on the driver? The restriction on the driver is that he should maintain his position in the traffic stream from start to end of the observation. Okay. Now, how do you maintain your position in the traffic stream? Let's say you were driving and a car from behind you came, and that driver passed you and came in front of you. A driver from behind you came in front of you. So your position is now disturbed. If you are third in the queue, now you are the fourth in the queue. Not the queue, because you are not stopping. You're not stopped. You are moving, still moving. But now your position is one car behind. Okay. So what you should do to maintain your position? Overtake the car. Okay. Overtake the same car which has overtaken you. So you will have your revenge, right? So it is sweeter if you overtake the same car, right? It's more fun. Okay. But it's not necessary. So that driver who overtook you was driving at 120 kilometers per hour, 150 kilometers per hour, and he went his home. You don't have to chase him to his house. Okay, you will end up getting beaten there. Okay, because it's his house. Okay, don't have to chase the same driver to and overtake him. Overtake any car, because you are trying to just maintain your position, and that's it. And so you overtake that driver or any other driver. Just maintain your position in the traffic stream. Okay, so this is what is the restriction. This is what the restriction is on the driver in floating car technique. He has to maintain his position in the traffic stream. Why? The reason is, if car, so you have only one lane, right? 2-lane highways, so one lane for one direction. If you want to know the travel time for that lane, and number of cars in front of you keep on increasing, obviously your travel time will also keep on increasing. You will keep on getting slower and slower. Okay, so in order to get the travel time which you can maintain in that direction, you must maintain your position in the traffic stream. So we want to keep the number of cars in front of us same from start to end. Okay, so these are the 3 methods of performing test car technique. Now an important issue is the number of test cars which you can employ on the site. So, for example, I want 50 samples of travel time. I want 50 observations. Okay, if I can arrange 50 vehicles with drivers and observers and stopwatches and pen and paper, if I can arrange all the resources required for 50 cars, 50 observations, and I employ or I let all the 50 cars go simultaneously on the segment. So these 50 cars will make one observation and my study is finished, right? Instead of 50 cars, if I can manage 25 cars, then my period of study will be more longer, because then I have to wait for each car to do 2 observations. So I have to wait for more time to get all the observations or to finish my study. Similarly, if I do it by 10 cars, so each car has to do it 5 times. So my period of study keeps on increasing when I decrease the number of test cars. So having more test cars is convenient for me because it will reduce my time, okay, my period of study. But these test cars are also increasing the traffic as well. So if you keep on increasing the number of test cars because you are the king of the country and you can employ as many test cars as you want, you are disturbing your observation because you are adding traffic to what you would have normally. So normally they would have been 1,000 cars. Now you have added 100 cars more. So travel time would be more than normal. Okay. So there's a limit on how many test cars you should run simultaneously. And that limit is 10. You should not run more than 10 cars simultaneously for any highway. Okay. Or for most of the highways. But if you have a freeway arterial, like for example, Sheikh Khalifa bin Salman Highway, Sheikh Isa bin Salman Highway, you know, these are very high speed roads, 3-4 lanes in one direction. On those freeways, and again, you don't have any intersections, you don't have any signals, roundabouts. So on those freeways, the limit can go up to 50 cars, but still there's a limit. So even for freeways, it's not unlimited test cars. It can go up to 50. Okay. but 10 is the most common limit which you can apply to all the types of highways. And why we are applying the limit? So that we do not disturb the normal flow of traffic. Normal meaning which would have been without the test cars. Okay. Other method of finding out the travel time is by license plate technique. In license plate technique, we have observers placed at the start and end point, or the entry and the exit point of the segment or the area. Okay, so we have observers at the start point, at the end point. What these observers are doing, they're recording the license plate number of the car which passes them, the registration number, the car registration number. So they record the car registration number and they record the time at which the car crossed them. So one observer recorded a particular number of car at 9 a.m. and the other observer at the end point recorded the same license plate number at 9:10 a.m. So it started at 9, it entered the segment at 9 and it exited the segment at 9:10 a.m. So it took 10 minutes to cross the segment. This car took 10 minutes to cross the segment. So this is the basic mechanism of license plate technique. Okay. The good thing about this technique is you don't need so many resources as you were looking for in test car technique. There are no cars required. There are no drivers required. No stopwatches required. Observers with pen and paper and simple watch can do it. Okay. Problem with this technique, two problems. One problem is you are only recording the start and end time. Okay. So you don't know if there was a delay during that time. So in these 10 minutes of travel time, if the car stopped for 10 seconds, 20 seconds, 30 seconds, you don't know. So license plate technique cannot give you the stop delay time which happened within the segment. It cannot give you. Okay. Second problem is to fulfill the sample size. Now, for example, you recorded 50 vehicles and the other observer also recorded 50 vehicles. To have the travel time, these vehicles should be the same. The license plate numbers which I have recorded and the license plate numbers which other observer has recorded should be the same. Okay, but when you are recording one number, the other cars are passing. So you have missed some cars. Okay, you do not record the license plate numbers of all the cars. So it may happen that you have recorded completely different 50 vehicles than the other observer. So obviously if the entry time is missing or the exit time is missing, then travel time cannot be calculated. Okay, so one observer may record 1,000 vehicles and in the end only 100 are matching. This can happen. Okay, even if you have very good observers and these observers are recording up to 50% data. So 1,000 vehicles pass and they are recording 500 vehicles out of them. This is a very good rate. Normal observers cannot do more than 20%. But even if they, let's say, they are going to the extreme, they are doing 50%. Even with this 50%, there's still a chance that you recorded completely different 50% vehicles than the other observer. There's a chance. Okay. So even with 50% data recording, the chance of matching is only 25%. 50% of that observer, 50% of the other observer. So there's only 25% samples which can meet, for which you can you can calculate the travel time. So missing vehicles and matching their travel time or matching their license plate numbers is a big issue in this technique. Other techniques which you can apply, you can observe the whole segment from a vantage point. Vantage point is a point of excellent view, a point from which the whole segment can be viewed from single position without any distraction. Okay, that is a vantage point from where you can view the whole segment without any distraction. So you are on a vantage point, you see a car entering your segment, you record the time it entered, then you record the time it exited or wherever it is stopping. So all the observations can be done. But the problem here is finding out the vantage point. It can be top of a building, over a bridge and so on. But all highway segments may not have a vantage point. Second point, I've already talked about it. So advanced variation of test cars. put a distance and time measuring device with the car itself, which will be integrated with the movement of the car. Or you can videotape the section. Now, videotaping can replace the license plate technique. So you have a camera at the entry point, camera at the exit point. Later on, from the videos, you match the license plate numbers and you find out their travel time. So this is videotaping using the basis of license plate technique. Or you can use it from a vantage point. So you have one camera which is recording the whole segment in one video, and you later on find out the travel time of each vehicle from the video. Okay, so this is videotaping, which is similar to the vantage point, the manual vantage point observation technique. Okay, so videotaping can work in different ways. Okay, but again, the problem is to find out a location where you can put the camera. Sometimes the view of the camera is blocked by a truck. A truck entered, it moving slowly, so till the time truck is gone, there is no other observation because the truck is directly in front of the camera. It is blocking all the other lanes. So all techniques have some, some restrictions. Okay, so this is where I will stop. So we have learned why do we do travel time studies and how we do it. So next time we'll continue further, inshallah. Any questions, any queries, any problems, please go ahead. Okay, everything is correct. Everything is clear. Okay, then have a nice day. Inshallah, I will see you tomorrow. And Assalamu alaikum from my side. Thank you for listening. Thank you for participating. See you tomorrow, inshallah. Assalamu alaikum.